what I'm going to do tonight is wrap up. I was going through 15 different points, and I'm trying to figure out how do I call these. They're kind of like perspectives, I guess. If we're going to be observing nature, then imitating nature in our designs and our systems, we have to know how to observe first. And when we do that, it's most useful to start with the big picture and patterns first, and look at the overview of everything with a wide lens. And then once you start looking through several of these wide lenses, then you narrow things down once you're inside one of those perspectives. And I haven't quite figured out how to describe that. Are they perspectives? Are they lenses? I've called them understandings. They're just like my big basket observational kind of categories I throw something in as starting points. And I may or may not have covered some of these already, but where I'm just about finished up on that. And then I'll just touch base on a little bit of seasonal update, what's been going on, and it ties in, of course, to what we're talking about. And so if I'm slow, or if I cough, I've got cough drops, I got other kinds of medicine, I got water, blah, blah, blah. All right. So we were talking about rocks. Now, some rocks like granite lead to soil above it that's acidic, and some like limestone form a soil that's alkaline. And if you ever get an opportunity to go to like a geology museum or something like that, just look up at the basic mineral elements. There's like these displays that'll have like a little card with a sample of each particular mineral element in its most basic form. They all have specific natural shapes, and they typically fall between this polarity from sharp and pointy to round. And silica exemplifies this sharp, pointy shape, and calcium has this rounded form. And what's interesting about that is those basic gestures, this pointy silica and this rounded calcium, the suggestions that mineral is in a plant or an animal, it's in there, and you can kind of see it in many cases. And so that's a real broad, coarse tool that helps you to dial in, because once you kind of can see the basic gesture and shape of the plants, the animals, the landforms, you can kind of get an idea of where you want to study next and where you want to narrow your focus some more. And we had talked the last time I was on here, of course, about impermeable rocks like granite, for example, that the water doesn't drain through them. So if you're going to have a flatter area on a granite bedrock, it's not going to drain very well. You have a lot of wet spots. And of course, the granite will as it starts to decompose, it creates a soil that's a lot more acidic. So this is in, I believe this was northern Maine. This is blueberries and cranberries, very flat, there's like hardly any soil. It tends to form peat in cooler regions where the rate of carbon deposition exceeds the rate of decomposition. So if you just can think about what I just was talking about right there, we have impermeable bedrock. It's granite, so it's going to trend towards acidic. It's impermeable, so it's not going to drain, so it's going to be wetter. And if there's cooler temperatures, you're going to have more carbon accumulation than you will have carbon decomposition. And that right there, just understanding those processes going on, you can understand a whole lot of things downstream from that. And then there's situations like this in Croatia. This is not tropical paradise. This is a highly calcium-rich water squirting up through, hydraulically squirting up through calcium limestone bedrock. So this is calcium, calcium, calcium. Here's just a picture to show you these basic shapes. And I think it's fascinating, this whole calcium silica polarity. If you think about silica, it has a special relationship to light, a special relationship to information, sensing, awareness. If you think about what's made out of silica, our computer chips, there's intelligence. Our windows is this light can be transmitted through our windows. And energy, our photovoltaic panels are made out of silica. I just find that fascinating that there's these associations with silica on the one side. Well, on the other side, the other polarity, this isn't, of course, it's not a black and white either or. There's a whole, spinning around continuum. These are just, observable polarities. Like the egg is the classic shape, this rounded form, calcium. If you think of things that are round, eggs, clamshells, your skull, even just the diameter of your bones, and so on. Things that trend towards calcium will be moister, they'll be cooler. You think about silica, it's going to be hotter, drier, that sort of thing.